This video is on optimization problem, and here I have a window here, and this is called a Norman window. And so what I like to do here is given the perimeter of this window here, I would like to find h and r, where r is the radius of this semicircle right here, such that the area here is maximized. And so here we have a rectangle down here, and then we have a semicircle up here. So find h and r such that the area is maximized. And so this is the Norman window again, and in this example I set the perimeter at 36 feet. And so the distance around the window here is 36. And if the radius is 3 feet, and so the radius of the semicircle here is 3 feet, and then h has to be 10.28761 since the perimeter is 36. And so notice that the perimeter is going to be 2h is this side plus this side, and then 2r, which is 2 times the radius, and then plus the circumference of the semicircle up here. And recall that for a circle, the circumference is 2 pi r. And so for a semicircle, it's going to be pi times r. And so the perimeter is 2h plus 2r plus pi r. And in this case, the perimeter is fixed at 36. So once again, if the radius is 3, and then if the radius here is 3, then h, or the height here, has to be 10.28761. And now let's change the radius. So when the radius is 2.8, then the height is 10.8, and then the area of the Norman window. And so notice that the area is just the area of the rectangle here, plus the area of the semicircle. So the area of the rectangle is just h times 2r, or 2rh, and then area of the circle is pi r squared. And so we have a semicircle here, so it'll be just half pi r squared. And so in this case we'll get 72.8. And then once again, our problem is we want to know for what dimensions, or for what h and what r will give us the maximum area. So now I'm decreasing the radius here. So let's increase the radius and see if we could find the maximum area. And so it looks like the maximum area is about 90.73. See if we could get a number bigger than that. So it looks like if the perimeter is 36 feet, then the maximum area is going to be when the radius is about 5.04 and the height is also about 5.04. And the corresponding area is 90.736. And so it looks like to get maximum area, then the radius and the height look like they have to be about the same. So let's go figure out what the exact dimensions are. And so once again, the area is going to be the area of the semicircle here, which is 1/2 pi r squared. And then the area of the rectangle is just going to be h times 2r. So we'll get 1/2 pi r squared plus 2hr. The perimeter, once again, is going to be h plus 2r plus h, and then plus pi r. Circumference for a circle is 2 pi r. So circumference for a semicircle is just pi r. And then in this case, we're given that the perimeter is 36. And then solving for h here, then we get h to be 18 minus r minus 1/2 pi r. And then so the area, now we can replace this h right here with the 18 minus r minus 1/2 pi r. And so the area now becomes a function of r is going to be 36r minus 2r squared minus 1/2 pi r squared. And our problem here is we want to find the maximum area. And so I'm going to take the first derivative here. And so first derivative here, we get 36 with respect to r. And then this will be 4r, and this will be pi r. And then let's go ahead and take the second derivative also. And so we do the second derivative, we just get negative 4 minus pi. And so notice that the second derivative is always going to be negative regardless of r. And now to find r such that the area is maximized, we set the first derivative here equal to 0. So we end up with 36. So move these two terms here, move them to the right. We get 36 is equal to 4r plus pi r. So the radius will be 36 over 4 plus pi. And so we want the maximum area, then the radius needs to be set to 36 over 4 plus pi. So let's find h. Earlier we have h is equal to 18 minus r minus 1/2 pi r. And so when r is 36 over 4 plus pi, then in the place of r here, we have 36 over 4 plus pi, 36 over 4 plus pi. And then right here, I'm going to multiply this 18 here by 4 plus pi over 4 plus pi, so that we have the same common denominator here. So notice that this is expression here is 1. So 18 times 1 is just 18. And so 18 times 4 would be 72, and then 18 times pi would be 18 pi. And then here we get minus 36, and then minus 18 pi. So we end up with 36 over 4 plus pi. And so to get the maximum area, the radius and the height of the rectangle here, they have to be the same. And then when we look back at the example here, we saw that when this area here, when it's maximized, the radius and the height here, we see that they're about the same here. And then when we calculate the exact answer, we also see that the radius and the height here, they are the same. And that's the end of the video.